In the beginning, I mean, let me go ahead and just open up the book really quickly so we could see. This book was really, or this chapter was really just about learning the process more than anything else. So it wasn't really about diving too deep. This project is going to give us the ability to dive much deeper. But as far as the process goes, it's like looking at the big picture. What is the problem we are trying to solve? Like, what's the goal? What's the business objective? Getting the data, so actually having access to that data, exploring and visualizing the data to gain insights, preparing the data, selecting and training a model, fine tuning the model, and then launch, monitor, and maintain your system. It all starts with what problem we're trying to solve, right? Because what problem we're trying to solve is going to determine which data we're using. Or we could pick the data and choose a problem from there. So, what do y'all think?
So every team has a product owner who's responsible for the business part and who defines the problem and figures out if we've solved that problem yet. And if you want to be a pretend product owner, there's lots of business problems you could make up. One would be staffing. Suppose that you own a taxi company and people are coming on shift on some hour of some date in different parts of the city. You're supposed to predict how many people should show up to work, right? In other words, you would need to model how many anticipated would occur during that shift.
Mm-hmm. Mm-hmm. Yeah. So the sky's the limit with the business problem.
One more thing. So, like, let's say we don't have any business problem and we just have the data. And then we have to come up with a business problem based on a solution which can based on the data. So one good thing what you can do is, let's say we have a data set of say 10 faces or 10 features. So we need to find out, so if, like we need to, so based on these 10 features, every feature is a candidate for being an output.
You're breaking up a little bit there.
I think it's my cut off.
Kind of affecting that
There.
correlate with that. And that way, like if we find like maximum number of variables correlating to the particular variable, we could think that that output variable could be efficiently uh, like a regression model can be efficiently applied on that output, because that way that is one another way to like come up with a business solution just based on data.
Mm-hmm. Mm-hmm. Yeah. So I just want to say, like, do we have to use these? I guess this would depend on the team that you're doing. I'm thinking of like we have access to this data, but are there businesses or nonprofits or like organizations out there who would be willing to give us data that the rest of the world doesn't have access to so that we could solve a like a real world problem that hasn't been solved before? I think of my buddy Greg. He started up a solar company in New Hampshire a few years ago, and they're not like the biggest. They're still in New Hampshire and Massachusetts, but he told me he's actually been collecting data in very strategically in a way where he wants to eventually apply machine and learning models to his business model. So I'm like, he's one of them. I would love to like help him out in a way that actually like solves problems for people who are trying to use renewable energy or something like that, or even just looking at like scratch him and people I know, but like just nonprofits or like government, or like, what is there a way that we could use data or solve a problem that's like real world? Like, I feel like that's more interesting for me, but I guess it comes down to what we want to do as a team. Yeah, we could hear you, dude.
Okay, wow. Ooh. I make an AI to figure out how to get this microphone working every single time you try it.
So what do y'all think about that?
So a complicating
Yeah.
a complicating aspect of what you describe is it sounds like multi-party NDAs, non-disclosure agreements, will need to be in place, and that kind of sounds like the kiss of death to a simple intro project.
Yeah.
So
I don't know. I thought Kaggle was like a good starting part, so like a starting point to working with like data sets that are based on like nonprofit organizations and at least there's like real world problems there that we can like
yeah,
participate. So
Yeah, yeah.
yes.
But keeping it separated from any real world application at like any, yeah, that makes sense.
You know,
So
I'm
one,
thinking we just want to take, any one of these free data sources and do sort of a chapter two kind of thing on it, as opposed to picking, our dream project that's going to involve, every chapter of the book, because we're not there yet. You know what I mean? Unless
yeah,
unless
you're
people are looking
actually
at,
you're right.
so I guess what are people thinking? I was thinking, we can grab something and do a chapter two situation and then kind of be done with it. And then, as we go to, learn more things in other chapters, then we'll start to get to something where it's like our own brand new idea of something, super cool. And that's where I'm thinking.
Yeah, that makes sense. Aditya, yeah, we can hear you.
Yeah, so like what Steve said, we are right. Like we can go with that approach, but so the thing is like the way they explained in the second chapter was they basically pick a data set of a particular domain, like housing cost. Now, obviously, like if we pick a particular project, I mean, not all data sets can be applied with the same technique. Like it depends on like how what the data set. So like we can start with that approach because we have to start with the same concept what they have done. But as we go ahead, there might be some new things which we might need to try on their data set based on how the data set is, how the structure is, how the nature of the data set is, how it basically correlates with each particular chapter and so on. That way, we might have to apply some new techniques. We cannot be sure to apply the exact techniques what they showed on the chapter 2, but almost lot of stuff would be overlapped.
Hmm.
So I would say like picking up a data set which is not too complex would be a better thing. For example, the taxi one, I know renewable. Like I'm trying to see like there is a data set called from EP20. That's a data set which is there. Now in that data set, like they do like lot of stuff like measure frequency. They're like indicators. They're like lot of stuff. So that might get a bit complex if we are not aware of that domain. We might just go around thinking about learning about those terms first, like what those terms are, and we would spend time on that, like more. I mean, that's how usually you do. You need to first understand what those terms are properly, and then you basically do the analysis.
I
So
think it's
I would say
important
like
for us.
something which is like very yeah, but yeah, for example, like there are some data sets like for example like the taxi driver which John explained. So that is not like that's like universal concepts like latitude, longitude, go from this place to that place. You are like aware of those concepts. So working directly with the data set, we don't have to spend time in understanding the domain. The domain is pretty universal to everyone, like to a common person. So I would say like better to pick for at least for this project, better to pick with that kind of data set which is like universal and we don't have to like do a lot of research on understanding those terms, what those terms are, and then we can move to like once we are aware of a lot of concepts, then we can parallelly we can like understand those concepts. We can pick a data set parallelly while going through the next chapter, and then basically everyone can just understand those terms a lot. Like, and then once we are done with the next chapter, then we'll start a new project. In this project, we don't have to worry about understanding those terms because most of us should be familiar with those terms. initial project should be better to pick like a project known, the domain is known to it.
Mm-hmm.
Yeah, and domain meaning like common knowledge, you know, working with
Yeah.
something that's common sense and is familiar with everyone.
Mm-hmm. Mm-hmm.
So this what we call a project is sort of gonna be to solidify, our chapter two knowledge, as opposed to, you could pick something crazy and then, apply chapter two to it, and then do chapter three and apply that and keep going. And or we could do just something that's the chapter two level thing, do it, be done with it, and then have another thing, and we're ready for the next thing.
Yeah.
And see, for the thing
Go.
you mentioned like the sorry, Jim.
No, do your thing.
The thing is you mentioned about the data set we are choosing. The chapter two had basically a discrete data set with like just like a two dimension, like I mean like a number of features and the sample, and then we applied regression. So we are going to choose the same data set, but my point is like even like the domain matters. Like in house values thing, like I mean the terms were terminologies were trying to be not too complex, and like the way explain like you I mean a lot of people wouldn't know that okay where to exactly that ocean proximity is more efficient, there are more matters as well sometimes for the house values. So those are some concepts. So the way they explained the project was pretty that made us clear about this concept. But if we choose a project now, if we want to do on scratch, rather than choosing like something like no one is there to explain and we have to this is one, and better to choose something which is like a university. That's fine. But the data set what you're saying, we are going to choose a single data set where we can apply the regression.
Mm-hmm. Okay. Yeah, I think choosing something that relates with everybody just so that all of us understand the language is a good idea. I'm going to go ahead and share my screen. I was just taking a look at the thing that JH sent. And yeah, if you look at this UCI data set, I was looking at the adult one, predict whether income exceeds $50,000 a year. This is something like we all work, we all make money. And I was just looking at some of the details here. So there's 14 features, 50,000 instances, which I think is small, actually. Like I'm not positive. I haven't done too many machine learning projects, but I think because even we had 20,000, I think, with the one that we did with the real estate data. So this is like a little more than double, but I think that's still small, right?
50K is not big data. And the two dimensions that you really care about would be, will it fit in RAM on my tiny little laptop, and will it annoyingly take more than a minute to crunch through all those rows?
Mm-hmm.
Yeah, and also it's dealing with classification. So, and I think classification is like a good problem domain that we can work on. So just comparing the categories of the data sets.
Classification meaning like either yes they make more than 50,000 or no.
Yeah, basically, yeah.
Mm-hmm. Can we instead of doing the classification actually predict what they make based on the data? Instead of just doing like a simple yes or no? I guess we need the labels, right? For what they actually make. What do you guys think about this? Because we have if it's just like a simple yes or no, that's what did you call the classification? You're basically classifying whether or not someone makes more than 50,000 or whether they make less than 50,000. But we've already worked on to more closely resemble the project that we worked through with the real estate. I think it would be a better idea if we can, instead of just saying yes they make more or no they don't make more, actually predicting what they make based on the data. I think that would be a little more challenging as well. But what do you guys think? And before we even dive into this data set, is this one that people want to work on, or
Uh, the thing is to choose to basically whether to like identify like how much they make instead of classifying. We need to see in that data set whether we have that particular variable to give you the exact amount or not. If it doesn't, if that variable is not there, then we cannot apply that regression. So what you're saying about finding the exact amount is basically regression.
mm-hmm.
So if that column is not there to tell you whether, so everything depends on what data we have. Based on that only we can apply an algorithm. So the taxi one which I said, so that basically is regression because there you need to give the exact value of what is the distance, shortest distance to reach, like time taken to reach from this location to that location.
Mm-hmm.
And also what Sweeper said about relating to chapter two, I think since we've worked on something uh, related to regression, I think we should focus on somewhere problem data sets that correlate to that. So, um, so that's my
Mm-hmm. You want to share the taxi one, Aditya, and just share how that would make sense for us to do?
Yep. Let me show you.
Because I didn't see the actual
Just one
income
table.
data either. Yeah, sure.
So this is the taxi one. So what it is, if I go to data, so yeah, over here. So in this comparison, basically your primary data set is the one used by taxi, UIC taxi, which includes pickup time, the geo coordinates, number of passengers, as well as other variables. So uh, what our main goal is basically here to, I can show you the data. Yeah. So all this data set is given based on the individual trip attribute. Predict Participants should predict the duration of each trip in the test set. So if I go to the train set, there should be a variable which basically tells you like the uh, time.
So they give you a pre-built training and test set.
Yeah, yeah, they give you everything. They give you like literally, I mean, all the stuff. So if you see like this is what they give. They give you like the train, the test. So you don't need to split your data. You have the train test separately. You might have to split your train into validation set for like cross validation, but that's the other part. But they give you train test and they give you sample submission. So the sample submission is basically the one where we have to predict the actual value. This wouldn't have the output values. They will be empty. This would only have the input variables. These two would have like the labeled values, the output variables also. So this one we have to like once our model is perfect, which we are sure. Okay, like okay, our model is done. Now it is ready to predict the stuff. So that dot predict function which we yesterday ran, it would be run. It would run on this particular submission data, and then it will also tell you what format the output will be, and then you need to submit the output. So that's how this competition goes.
I think that's pretty useful having just the test set and the training set like
Yeah. It
already.
also explains you everything, like what
Yeah,
each
in the features.
factor is, everything.
Yeah.
So this is the one
Uh,
trip duration.
I like this. I like this data more than the other one where you're guessing what your salary is.
Yeah,
And
this is regression.
we're trying to estimate the time of the duration. Is that
Yeah, so
what we're trying to calculate?
these are the variables input variables that the vendor ID, pickup location, lag pickup, actual non pickup location, where you're going to drop. So the start and the end point of that trip, and some other parameters, and then the trip duration. So this is the training data given. So in the output, all these variables will be given, and you need to predict what would be the value.
Yeah, that sounds interesting. You know, and then if it's a ton of fun. I mean, what my brain jumps to is, you know, I wonder if we could make any if we didn't have the drop off date time, what could we figure out just based on everything else? You know, about what the trip duration. You know, is that a crazy
No, I didn't get you.
idea?
No,
I
that's
mean,
one of the steps in the process is using these attributes to create new attributes that are also useful attributes or that have correlations. So yeah, that's definitely part of the process, like mixing and matching to
I mean,
create different. Yeah, yeah.
it's almost like like on the what we're starting off with. It's a great problem and it's fascinating. And then I guess I just wonder like if you took out a piece of the data, basically the drop off. Can you know estimate a time of duration based on just where
Yeah,
someone
like it
picked up? I
predicts.
mean,
Right.
that might be it might be crazy because it might be so unpredictable that it makes no sense. On the other hand, maybe some of the time when based on where somebody gets picked up, it does give you a clue
So
as
this
to
date
like
time,
quality.
it is related to the traffic, I think. This date time. So at spike,
There's
usually it is
already a
like peak
variable.
hours when people wake up.
There's already a variable that's missing from this. Each year, Manhattan has a bunch of parades for different reasons, and those are not labeled here. But a question you could ask of the data set is what times and locations had major parades that disrupted traffic?
Oh yeah, that's actually interesting. Like uh, blockades of of like the traffic is it can be an interesting problem statement too.
No, the problem statement doesn't give anything about the traffic, but we can infer about the traffic. That what routes are kind of more highly like kind of cluttered during what time in the entire city of New York. So that could be one more other inference we can make and another problem.
Mm-hmm.
So
Yeah,
there are a lot of stuff we can look at.
but I just realized I haven't read every part of this, but is the trip duration not just the pickoff, the drop offs subtracted from the pickups?
No, 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 no. That's what I said. Like what you're saying is basically without any kind of noise, right? But there are noise factors involved, right? Like it's not like it's not just your car. Like you also need to like see and what speed that car is going. That also matters. So like how much traffic is there? How many signals are there that between that distance? So what are the different routes to reach from that location to that location? Everything matters.
So is each row a trip by a recorded trip?
Looks like there's a unique identifier for each trip.
Yeah.
So
So yeah, each trip, each record is one trip, entire trip, irrespective of the what vendor it is. So that vendor we can get from this, like what vendor ID. So that would be another inference, like which vendor ID is actually like making customers reach on time. So what are delays?
how
So
many how many trips are we analyzing? Does it say the um
Uh, I need to sign in. I'm having some issue with sign in, but you guys can like sign in and check just how many data set, like how many data is there.
Scroll to the
okay.
top and it mentions it.
Oh,
I
yeah,
think
oh,
it's
it's
point
there.
0.6
It's there.
million
Oh,
tests.
yeah,
Oh, dang. Nice.
yeah.
Oh, okay. So
It's
that's
14 million train set, 6 million test set.
Yeah, 1 million, 1 million,
Oh, 1 million. Sorry.
5 million. Yeah.
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 Okay, well that's a decent size of data then. It would someone consider that large data, big data, or is that still small? Just curious.
I mean, how
This
many
is
megabytes is that?
pretty good.
89 megabytes. It's like a small data set.
Yeah. I mean, it all depends on, like, I mean, there are two things which I have known. One is the volume, second is the variation. So, like, yeah, the volume is good, but if the data is not varied, like, I mean, if it's, let's say, just like a lot of, or most of the data, let's say 50% of the data is just on one street. So, like, that won't give us like much better results. So, all a lot of we have to check like the after we have to analyze the data and see how is the data, like by plotting the line graph from pick up to drop location, and see on a graph like on a map or something like how the data is basically how, like, what's the variation.
Mm-hmm, mm-hmm.
Do we
Yeah,
want to jump? Do we want to jump into this right now? Is this something we want to do in this meeting, and Jim or somebody can are doing it, or do we want to sort of all do this on our own, or?
I'm down for this. Yeah.
Well, I believe we're gonna break into teams of three people on each team, right? So do both teams want to do the same thing, or a different team's gonna do? Because that's cool with me. I think that might actually be a good idea if we have two teams working on the same thing, because then teams that get stuck can kind of like they can help out the other team, that sort of thing. Or we could work all as a group. What do you all think? Yesterday we were saying teams of 3 or 4, and today we're all just discussing it together. So what do you think
Yeah,
is best?
it's people here, so I mean, I think that's like a good, reasonable group that we can work on. I mean, honestly, it's a really small group too. So
I'm happy either way. You know, it could be interesting to see how the two separate groups, go on, down different paths and come up with
different.
a different, strategy and result. That could be interesting to dig into. If one gets a better, model than the other. But it's also easier just to have everybody on one meeting and just do it.
Hmm. Yeah, yeah. I think everyone sticking together for now would be a good idea. Just
Good.
it would be easier. Let me